Well, as I talked about yesterday, the pattern is, like saying it, locked and loaded for cold and the threat for storms. AccuWeather.com meteorologist Bernie Rayno. I want to show you what's going on right now. Satellite picture. This is that Arctic front that we've been talking about. This is starting the process of just some brutally cold shots coming into the Midwest and eventually all the way down into the Southeast. And we already have one front. You see that? That's been causing problems across Texas and all the way into Louisiana. But here's our next Arctic front that is going to be coming to the east this weekend. Now, my good friend Ever Myers and Elliot Abrams talks about this storm, what it's going to do Friday night in the upper Midwest, Saturday along the East Coast. And then there's another system that's going to be coming down in its wake as we head in the Sunday and Monday, Sunday night into Monday, and that is going to be producing some snow. Again, Evan and Elliot Abrams talk about what this storm is going to be doing to the east, and we're going to be getting snow. While most of it may be north of the big cities, there's going to be some this weekend. Now, what happens behind this storm is that there's going to be just an even colder shot of air coming behind it. I want to show you the surface map. And I showed this yesterday. And this is for Tuesday afternoon. Look what you have here. I'll zoom back out so you can see it. First of all, you have high pressure. 1040. Now, that number is significant because the higher the pressure, the colder the air, right? Well, this high pressure, 1040, just a brutal shot of cold air coming behind it. And what you're going to end up getting is that behind this storm, the frontal boundary associated with it is going to be able to drive all the way down into Florida. And by the time we get into next week, it's going to be stalling somewhere along the East Coast. And as I've been talking about yesterday, with this continual flow out of the Northwest around a big upper low over Hudson Bay, you're going to get more energy dropping southward. So what you end up getting is you have a boundary. And remember, that boundary is the location where you can get storms to form along it. Why? Because you have warm out ahead of it, cold behind it, a big temperature difference. I want to show you what this is going to look like. This is the surface temperatures Tuesday night. What you're looking at here is this red line is the 32-degree line. This is Tuesday evening, all the way down to I-20, Dallas, Baton Rouge, south of Jackson, Mississippi, all the way toward Birmingham, Atlanta, Columbia. The whole length of the I-20 is where it's 32 degrees or below. Now, that's all, and by the way, look at this. Look at how much, about a third of the country on this is below zero? So you have cold air in place. Boy, once you get cold air established, snow always tends to follow it or be along its edges. And what I'm concerned about next week is look at all this cold in the blue. You see it, blue and purple. It covers much of the eastern half of the country, but then you look offshore, look at all this. Look at that warm water here, 50s and 60s. So right off the bat, you look at this, well, here's our boundary. So it's not going to take much for a storm to form along this boundary. And what we've been talking about is that as you take a look at the jet stream, and as we go into Tuesday night, you have this energy. Now, this is the American model. You have this energy coming behind the upper level low. I'll zoom back out. And it's this energy that drives southward that can form a storm. Now, the GFS model is not that. It's not as impressive as it was yesterday, but you still, let me show you the difference. This is the American model. If this would be right, what storm that does form along the coast would be out to sea. There would be a little snow in eastern North Carolina, but I'm still concerned that when you look a little different, this is the European model. See the difference? See, this energy is way up here across Kansas and Missouri. The European, it's way down here, down across Alabama. So when you look at this pattern, what my concern is, again, here's your northern piece. See, you have like two little branches of the jet stream. This is separate from this. And what ends up happening, if this is your northern piece, this is my southern piece, right? This will guide, well, I got to go this way because my arm doesn't go that way, but it ends up taking the southern piece and guiding it northward. And that's where the concern is, that you can get a storm coming up into the Carolinas and right up the mid-Atlantic. Let's remember, you have Arctic air in place. All right, you have a boundary sitting here. It wouldn't take much for a storm to form. Now, if the whole look of this jet stream has to be right. If it's not, the storm, yep, it'll form, but it'll be offshore. But if this energy, again, if you get this kind of, well, you get energy here, you get energy up here, so there, in a sense, it's two pieces. This acts as an anchor and in a sense guides this up the coast. And if this happens, this would be a big snowstorm. At least there will be some snow, but it could be a big snowstorm. From anywhere from the Carolinas all the way up to Washington, D.C., Philadelphia, New York City, and up to Boston. I don't believe this will be in northern New England. But this is the threat zone, just like yesterday. Is it going to happen? I'm not sure. I'm not smart enough to say that I know the answer to this, but I think you have to continually look down here for the middle part of next week, Tuesday and the Wednesday. In this zone, this is where you have to look for the possibility of a snowstorm. I'm not hyping it, I'm just telling you what the possibilities are. So really no changes from yesterday, all right? I mean, this is the pattern we see. Jet stream down to the south, front, storm forms, and up it goes. I'll have an update later on today. If you have any questions, you can follow me on Twitter at Bernie Rayno.